Upon receiving medication, the temperature of a patient in a hospital on day D of an illness is given by T of D is equal to this equation, degrees Fahrenheit for 1 is less than D is less than 5. Find the equation for the instantaneous rate of change of the patient's temperature in terms of the days. What does that tell me to find? Instantaneous rate of change is the derivative. So this is really saying find the derivative. Your brain should translate that. I want you to hear or read instantaneous rate of change and say, take the derivative. That's what I want your brain to do. Okay, take the derivative. So part A is going to be the derivative of this guy. That's negative, so T prime of D, negative 2D plus 5. How is that? That was easy, right? B, find T prime of 2 and interpret your answer. So I plug in 2 for D in the derivative, negative 2 times 2 plus 5. So I get T prime of 2 is, guys, listen up, please. Oh, did you guys oh yeah, pass the around. Sorry, I didn't get everybody. Sorry, I stopped because I was checking homework.
You have, Jacob?
All right. Okay, what are my units? Help me out. What are my units for the derivative? Derivative is slope, so it's just y over x. Temperature is measured in degrees Fahrenheit, right? Right? And then what does D represent? Days. So per day. So listen, if I was a doctor and I was telling them, okay, what was I going to say, like for T prime of 2, what does that mean for my patient? They what? Well, they've had it for 2 days, but what does 1 degree Fahrenheit per day mean? So I would say on day 2,
Fahrenheit, if they're sick for 1 more day.
Yeah, the temp will increase by 1 degree Fahrenheit for 1 more day. Or you could say will increase at a rate of 1 degree Fahrenheit per day. Okay, thank you very much. Good. Letter C, instantaneous rate of change on day 3. Okay, ladies and gents, you have to know what this means to do. If I say I want the instantaneous rate of change on day 3, what do I do with that? What does that translate to mathematically? Yeah. I do T prime of 3, right? That's what that means, right? I straight up asked you to find T prime of 2 in part B, but here I'm asking you to find T prime of 3. So I plug it in, you get negative 2 times 3 plus 5, which is negative 1 degree Fahrenheit per day. What does that mean? The patient's temperature is what? Patient's temperature is increasing or decreasing?
Decrease.
By 1 degree per day. So in part D, if you're a doctor, what would you tell the patient based on your findings? We can just talk about it. What would you say? After what? Day 3.
Your
Temperature should
decrease
decrease
by 1 per day.
Yeah, your temperature. I would probably just tell my patient. I was like, hey, like, it looks like on day 3 of this illness, your temperature is gonna decrease and start going back to normal. That's what I would say, right? Okay. I showed this to my brother who's in med school, and he's like, "Oh, nice." Okay. All right. Do you guys have any questions for me on the differentiation jury? Any questions for me on the differentiation jury problems? Is there one that we had the most trouble with or anything? Okay. All right, get out those notes. I think one of the reasons I love calculus so much is for all of the calculus jokes. I have a whole document of calculus jokes that I've been putting on your worksheet. All right. Yeah, don't drink and derive. Not good. You don't be writing while you're driving. Okay. Today's topic is, we have like it's twofold. So we're going to analyze a graph, and then we're going to dig deeper into trig derivatives. Okay. So here we go. If I look at this graph, remember the derivative is the slope of a tangent line. That's another catchphrase I want you to associate, right? Instantaneous rate of change, slope of the derivative. What's the financial word for derivative? Marginal. Yeah, good. So if I know, think of it graphically as the slope of a tangent line. So I'm asking you to like analyze this graph over here. I've drawn lines on it down here just to kind of make my point. But I'm asking you to look at it and say, okay, I'm giving you an X value, and I want you to tell me if the derivative is positive, negative, or zero. And I want you to tell me if the function f of x, this is f of x, right here. And I want you to tell me if that's increasing, decreasing, or at a relative max or min, okay? So at x equals -7, right? This is what, like -2, -4, -6, negative, here's -7, right? So on this line, do you see this line here? I drew my tangent line, right? My slope at x equals -7. Does that make sense? That point there? Okay. Is this a positive, negative, or zero slope? It's positive. It's increasing. Okay. Which means that f of x, is f of x increasing or decreasing here? It is increasing. It's going up. So it's increasing. Leave a little space there because I'm going to have you write an interval, the interval on which it is increasing. So at -6, now I'm on this one. Is the slope, is the derivative positive, negative, or zero? It's positive, right? How about at -4? That is, oh, so by the way, if it's positive, that means the function is increasing.
It's zero.
The slope at -4 is 0, right? What does that indicate? What do you notice about f of x there?
That's the relative maximum.
It's like a maximum. It's a relative maximum of the function, right? It reaches a peak and then comes down. So that's why we say relative max. It's not necessarily the highest peak, but it is a peak. Okay. So we say it's a relative high point. All right. So what is the relative high point of your life? Okay. So this is 0. We have write this verbiage down. Relative minimum.
Wait, what is the minimum and maximum?
I'm sorry, maximum. I don't know why I said that. Relative maximum. Good catch. Trick or treat. All right. At x equals -2, is this a positive or negative slope at -2? It's negative, right? It's sloping down. All right. Is f of x the original function? Is that increasing or decreasing? It's decreasing, right? So it's decreasing. How about at -1? -1 is still decreasing, right? Still decreasing. And its derivative is negative. How about x equals 1?
Minimum.
Minimum. Look at that right there. It is a minimum. So my derivative is what? My derivative is 0, right? The slope. Remember, the derivative is the slope, which is 0. So listen, are you hearing this? When the derivative is 0, we have either a relative maximum or minimum at the function. That's how you find your peaks and valleys. That's how you find your high points and low points. When you set the derivative equal to 0, do you hear me? Derivative equaling 0 is a relative max or min. In this case, this is a relative min. Later on, I think in chapter 3, we're going to use a derivative to determine if it's a max or min. We don't have to do that right now. At x equals 3, positive or negative? X equals 3, positive. And so f of x is increasing. How about 5? 0. So that means it's a max, relative max. And then 7, decreasing, it's negative. Okay, here's what I want you to do now. Let's make a jump. I want you to tell me the interval on which based on f of x, I want you to tell me the interval on which g of x is increasing. So you can say, or sorry, f of x. F of x is increasing on what interval? Well, my derivative is positive all the way from negative infinity all the way to what x value? -4. So I would say it is increasing, increasing on negative infinity to -4. And anywhere else? Where else is it increasing? Ooh, check this out. Right? 1 to 4. Okay. Or I'm sorry, 1 to 5. Thank you. 1 to 5. Yeah. Okay. Because that's where the. Okay. All right. So here's what I'd like you to do. Take a look at this graph. There we get that. Sorry. Okay. Take a look at this graph. And I want you to write the intervals where g prime is less than 0. So if I'm asking for the intervals on which the derivative is negative, what should I be thinking about? If this is g of x, what should I be thinking? Where is g of x? Decreasing, right on, right? And if I want the intervals where g prime is positive, right? It's where it's increasing, okay? All right, so go ahead and do that. And where the values of x where g prime is 0. Oh, that's annoying that it get to the next line. Take a minute and do that. The derivative tells us about our original function. The negative tells us the original function is decreasing. The positive derivative tells us the original function is increasing. And a derivative equaling exactly 0 is a max or min.
Isn't it in January?
So if this is, if g prime is negative, it tells you where this is increasing. So where's the interval?
I guess not last.
Right here. So I would say g prime has to be negative from x equals
Close enough.
-4 all the way to -2. And then also. Yeah. How do you do? We come up with stuff? Okay. Fine.
That's what you just said.
Wondering where
You literally said maybe I
That's
could do
exactly where g is increasing. There's an interval where g is
that. No,
increasing.
June, is that not what she said?
So from the x values, okay, -4. Maybe this other, right? So really you just have to know, hey, if I'm asking for a negative derivative, that's where the regular function is. Okay, so g prime, derivative negative, original function decreasing here and here where I've highlighted in yellow. So I would say g prime is negative when the original function g is decreasing from -4 to -2. And what's the other interval?
1 to infinity.
1 to infinity, correct. Okay. Now I'm looking for where g prime, the derivative is positive. When the derivative is positive, that tells me the graph is increasing, right? You were doing that with your word problems, right? When you get a positive answer for the derivative, we're saying, oh, it's increasing at a rate of. So it tells me about the original function is increasing. Let's see, here in blue and here. So I would say increasing on -infinity to, you got it, -4, and then -2 all the way to 1. Does that make some sense? Okay, hopefully. And then where is g prime equal to 0?
Therefore,
At -4, because that's a max, and at x equals, not 2, try again. So that's where g of x equals 0, but where does g prime equal 0? G prime, the derivative is 0 when we have a max or min, right? So at what? Oh, I'm sorry, I missed that one. Yeah, I'm sorry, -2. I thought you said 2. I thought you said 2. -2, yep. So -4, -2, and 1. Sorry about that. I heard +2. But that I think it's because I saw immediately that was a 0 in the function. I was like, yeah, good. Okay, next topic. There are derivatives of 6 trig functions. Okay, get out your handy dandy derivative sheet, your formula sheet. Get out your formula sheet, and you'll see all of these there. So formally, getting out the derivative sheet. Formerly, I told you the derivative of sine x is cosine x, right? Guys, listen. If we're talking, we're not listening. All right, thank you. So I told you the derivative of sine is cosine, right? However, I left out some details because I can put whatever I want in the function, right? I can say the sine of 2x, right? All I taught you so far was how to find the derivative of sine of x, plain old x, right? But what you do and what your derivative sheet tells you is the derivative of sine of u, any quantity for that angle, is the cosine of u times, check this out, u prime. So what you do is you write sine's derivative is cosine of exactly what that quantity is, and then you take the derivative of u, right? You take the derivative of what's inside, okay? For cosine, it's negative sine of u. It's just this cosine u turns into a negative sine u, and then you multiply it by the derivative of what's inside, okay? That part is usually pretty easy. The tangent of u has a derivative, and it's secant squared of u times u prime, the derivative of what's inside. Cosecant of u, and again, you don't have to memorize these. If you're in AP Calc, you'd have to, but we don't have to. So cosecant u is negative cosecant u cotangent u times the derivative of u prime, right? They all take their derivative and then the derivative of what's inside. Secant u tangent u times the derivative of what's inside, derivative of u prime, Cotangent u is negative cosecant squared of u, so exact same quantity of u, then take u prime. All right, let me show you. So basically, the generalization here is you write the derivative trig function, and then of that exact same quantity, and then take the derivative of the quantity. Let me show you an example. So we have 2 sine of 2x, okay? Let's say y prime is going to be, all right, when I have a number in front, I know that's just going to be a constant multiple. That's just multiplied by 2, right? What's the derivative of sine of 2x? It's going to be Derivative of sine is cosine of 2x, right? It's the derivative cosine of the exact same quantity, 2x. Then, what's the derivative of 2x? Because that's u prime, right? What's the derivative of 2x? That's easy. 2, right? That's the derivative. And then we just got to clean it up a little bit. So I can multiply, I can't touch the angle, right? This 2 and the 2 on the end becomes 4 cosine 2x. Does that make sense? Now, I will say, I'm going to ask you most often about derivatives for sine and cosine and tangent, because they're the biggest ones that come up. Okay, I'm not going to ask too much about the reciprocal functions, but I have a way to remember, because it's just easier as you're going through problems to, not that you have to have them memorized, but sometimes it's a little more convenient. Here's a little memory trick. I remember CNS. So CNS, the derivative of sine is cosine. And then the derivative of cosine is negative sine. Right? So I'll do that. I remember CNS. Derivative of sine is cosine. Derivative of cosine is negative sine. CNS. Cosine, negative sine. Cosine, negative sine. Okay? Anyway, if you like that. All right. Go ahead and try the your turn problem. See how you do. Try the your turn problem.
Negative sign. Wait, doesn't see it.
Now. So f prime of x is going to be, remember the u here is x squared. Does that make sense? It's whatever your angle is. So you take the derivative of cosine, that's negative sine. So negative sine, copy the same quantity of x squared. We have till 33 or 34, whatever it is. So, this is Halloween yet. So negative sine x squared. Now listen, I need to take u prime. So I'm taking the derivative of x squared. What's the derivative of x squared? 2x, right? All over 2. Can I cancel these 2's? Yeah, it's not in the angle, it's multiplied. So my answer is negative x sine of x squared. F prime is negative x times the sine of x squared. Good. I think I may have missed looking at the x over there. Okay. Let's do another one. Find the derivative. G prime of x. Okay, derivative of 4x squared is going to be easy. What's that? That's the power rule. So 8x. Yep. Tangent of 1 over x to the 4th. Okay. The derivative of tangent is tangent of u is secant squared of u times u prime. So secant squared of u times u prime. So I take the secant, the tangent turns into the secant squared of the exact same angle, right? I just copy it. Copy paste. Just change the tangent to secant squared, right? That's its derivative. Take the derivative of the trig function times, what am I taking the derivative of for u prime? Yeah, so u is 1 over x to the 4th, which is, Logan jumped there, x to the negative 4, right? So my derivative is going to be the derivative of x to the negative 4. What does that turn into? Negative 4x to negative 5. Okay.
Oh, sweet.
Any questions so far?
Oh, man.
Okay. Now, clean it up a little bit. G prime is going to equal 8x plus the secant squared of 1 over x to the 4th. Oh, I'm sorry. I should have a minus 4, right? I'm going to put that minus 4 in front. Yeah. Where does that x to the negative 5 go? In the denominator, quotient, yeah. X to the fifth. It becomes positive in the denominator. So I brought my constant out front of the trig function, brought that -4 in front. The angle stays there and it's all over x to the fifth. That's it. These can be tough. So just take it slowly. Go ahead and try your turn 3. See how you do. You got 2 more left. And I'm gonna write it up as you go because we have a little bit of time. This one's pretty easy. Did you get secant squared x minus 1? Okay. And then, can I just show you this last example real quick so that you have it? Okay. Yeah. Because there's the only thing that was in there was x. All right. Derivative of this is going to be 2x, right? That's easy. Now, what's the derivative of cosine? Negative sign. So it's negative. I do have one more minute. Sorry, just keep you for a second. Negative sign of the exact same quantity. And then take the derivative of this, which is 2x plus 4. So then I can just write that in front, clean it up, and you get this. Minus quantity of 2x plus 4 times the sine of x squared plus 4x. That's it, okay? Hey guys, suggested homework is the 2.2 worksheet 2. Okay? It's only 9, oh, I guess it's 14 problems.